Well, hello, pre-calculus students and seekers of general truths. In this video, we will take the concept of future value of an annuity and extend it to a very specific example of borrowing for a home, borrowing money to buy a house. This is what many people in America do. All right. So let's look at this scenario. To buy a house, we borrow $80,000 from the bank today with an annual percentage rate of 4% compounded monthly. So the present value of the loan is 80,000 and the future of value is how much we would owe in 30 years with all of the compounded interest. So first things, let's calculate the future value of the loan. Well, this isn't too hard to calculate, but we just got to be mindful of what formula, what equation to use at this point in the course. There are many of them, and it's key that we are able to make sense of all of these equations in all of our work. All right, so set this up. This is not an annuity situation. This is the case where somebody is giving a lump sum. In this case, the bank is giving a lump sum of $80,000, and they're getting 4% interest on their loan, right, compounded monthly for a period of 30 years. So 12 times per year for 30 years. And if we type this into a calculator, we get kind of a frightening amount of money. This is $265,079.84. So this is kind of like saying that, sorry, not kind of, this is like saying that if we were to ask the bank for $80,000 today, if we pay absolutely nothing on that loan, in 30 years, we would owe $267,079.84. So you owe more than 3 times the amount that you pay for it, right? And nobody saves up that money in 30 years just automatically. And no bank would ever make this sort of deal where they give you money and then 30 years later they come back and ask for 3 times that amount. So the way that loan structures are set up is we take the amount, the future value of the loan, and we set it equal to an annuity. Okay, so the bank says, okay, you're going to owe me this much money in 30 years. And what I want you to do is deposit a certain amount of money, let's say R, into an annuity every single month, because we're doing this compound is happening monthly, right, for the same exact number of time for the exact same interest rate. So we're going to match up the future value of the loan with the future value of the annuity. So future value of the loan is $265,079.84, and we're going to set this up equal to the equation for an annuity. So this is 1, remember, minus 1 plus 0.04 divided by 12 raised to, this case, in the 360th power, all divided by 1 minus 1 plus 0.04 over 12. All right. So it's a fairly simple equation. It looks complicated, but it's just a number on the top here, a number on the bottom. Solve that out and divide both sides to get R. Okay, so I'm going to do this nice and slow. So just all of this expression right here together gives me 694.0494. All right, so R times that number is going to be equal to 265.79.84. All right, and then divide both sides by 694.0494. And we'll have our final answer, which is something much more reasonable and nice. It turns out to be approximately 381.93, and that is equal to R. All right. And so yes, this is how a lot of banking calculations work, especially for home loans. 30 years is a common number of years that a person could borrow a loan. And this $381, it means that that's how much a person would need to pay every single month for 30 years in order to accumulate $265,079.84 over a period of 30 years. Okay, so rather than coming back in 30 years and asking for this huge chunk of money, a bank would just say, pay me this much, 381.93 every month. Okay, and that would be the equivalent home loan payment. All right, so we see here a fairly straightforward example, although the numbers are a little bit messy, but the key again is that we set up the future value with interest, right? And we set that equal to the annuity with interest. All right, so hopefully this gives you a better understanding of loans and the mathematics of finance. We're going to work on some more examples that are a little bit more complicated, but they really build off of this same concept. As always, keep working hard, ask questions if you need clarification. Thank you for watching, and have a wonderful day.